Okay, so for this particular lesson, we're going to graph linear inequalities. And a linear inequality in two variables is the result of replacing the equal sign, which we have been normally doing, with an inequality symbol, such as less than, greater than, less than, equal to, greater than or equal to. The graph of a linear inequality shows a set of all points that represent all solutions on the inequality. So the first one says, tell whether or not the ordered pair is a solution. So the idea is if you substitute in the x for the x, the y for the y, and you do the math, 3x minus 4y, is the answer really in fact greater than 9? Well, let's see. 6, sorry, y was 0 here. So 6 minus 0, is that greater than 9? Is 6 greater than 9? And it's not. So this particular ordered pair is not a solution. Let's try the next one. And the next one's the same idea. You're going to replace the x for the x and the y for the y. Trying to get this thing to come up a little bit. No luck though. Here we go. So then what happens here is I say 3x minus 4y, is that greater than 9? Do the math. 6 plus 4 greater than 9. 10 is greater than 9. So yes, this particular ordered pair is a solution. Okay, so let's start talking about some other stuff. When you graph linear inequality in two variables, you need to graph the boundary line. Now, when we did stuff with number lines, we used open circles and closed circles for inequalities. Now we're going to use dashed or dotted lines and then solid lines. So if you have an inequality symbol that happens to be either a less than or a greater than, the kind of line that you want here is a dashed line. So you're going to use a dashed line. In other words, you're going to have a line that looks like that if the inequality is a less than symbol or a greater than symbol. You're going to use a solid line, which is what you normally graph with if you've got a less than equal to or greater than equal to. You then have to figure out where to shade. So you're going to test a point that's not on the boundary line. And we tend to use 0, 0, the origin, as your test point to check whether that 0, 0, that ordered pair, is a solution of the inequality. So if that happens, you're going to shade the side, or the half plane is what we call it. It's not necessarily going to be exactly in half, but you'll shade the half plane containing that point if the ordered pair is a solution, or you will shade the other half plane if the ordered pair is not a solution. Okay, sounds like it might be confusing, but really it's not. Alrighty, so when you start doing some of these problems, this first problem, look at the inequality symbol. It is just a less than symbol, which means in terms of its line, it's going to be a dotted line or a dashed line, whatever you want to call it. So when you actually graph this line, you begin at positive 4. With your slope, you go down 1 over 2, down 1 over 2. You're going to extend your line all the way across your graph. So you have two sides to the graph. It's a dotted line. So I'm going to take a dotted line. I think that's a dotted line. And I am going to extend my line all the way across my graph. Well, now I have to figure out, where do I shade this graph? Do I shade the top region or the bottom region? We're calling those things half planes, even though they're not really half of the graph. Well, I'm going to pick a point, and we usually ask you to test 0, 0. If I test the point 0, 0, and I plug it in for the equation, 0 less than 1/2 0 plus 4. If you do the math, let's see if this is true. 0 less than 4, because 1/2 times 0 is 0. Well, 0 is in fact less than 4. So we're going to shade the half plane where 0, 0 is. So we're going to shade everything in this bottom region. Any point in that region would be a true statement if you plug that ordered pair into the original equation. Let's try the next one. This next one has a greater than equal to. That means that we're going to have a solid line. Well, x is greater than 4, or greater than or equal to 4, is an excited line that runs through the 4 on the x-axis. So I extend the line all the way across. Now I have two sides of this line. I've got a left side and I've got a right side. Well, we're going to take that test point again. That test point is 0, 0. When we plug in that test point 0, 0 into the equation, there really isn't even a y-coordinate. There's just an x-coordinate. Is 0 greater than or equal to 4? And it's not. This is a false statement. So you can't shade where the 0, 0 is because it's not true. You have to shade the other side where the 0, 0 is not. This should make sense also because if you think about numbers greater than 4, numbers greater than 4 would be numbers like 5, 6, 7. They would be everything to this right side anyway. So there's a little bit of common sense in this as well. Okay, let's try one more. Inequality symbol, it's a greater than, which means you've got a dotted, dashed line, whatever you want to call it. You've got to solve this thing for y equals minus 4x on both sides, negative 2y greater than negative 4x plus 8, divide by negative 2, divide by negative 2. Y, now don't forget the rules for dividing numbers, inequalities by negative numbers. You have to flip the symbol. That's an old rule. Y is less than 2x minus 4. So now what you do is you find minus 4. You go up 2 to the right 1, up 2 to the right 1. It's a dotted line. So I'm going to do a dotted line here. There it is, all the way across the graph. I've got two sides, basically almost like a left and a right. I'm going to use the test point 0, 0, and I'm going to plug in 0 less than 2, 0 minus 4, 0 less than negative 4, and 0 is not less than negative 4. This is false. So you're not going to shade the side where 0, 0 is. You're going to shade the other side. Okay, so that's it. Good luck on your homework.